Hello students, once again I welcome all the standard 10 students on this online classes. Last class we have discussed and we have learned about principle of moments, torque and its unit. But today we will discuss about principle of moments and verification of principle of moments. How to calculate the principle of moment we will discuss here. So let's start this one. We have seen the beam balance in the grocery shops. Yes? The shopkeeper uses the beam balance to weight the items. Shopkeepers are using that beam balance to weight the item. Whenever we are asking for 1 kilogram of some items, they are measuring that one by the help of a beam balance. In normal condition, the moments due to the pans are in equilibrium and the beam is horizontal. It is balanced condition. Here you can see that one, that beam balance is balanced one, and equilibrium condition it is present. But what happened when we put some weight on one pan keeping the other empty? This equilibrium get disturbed. Obviously it will happen. The pan capped with the mass moves downward and the beam rotates due to the unbalanced moment by the weight. On which pan we have kept that weight, that side pan will be moves downward direction and other empty one will moves upward direction. Here the unbalanced moment causes the rotation of beam about the fixed pivot. Similarly, a seesaw when empty stays in horizontal position due to balanced moments about the fixed pivot. If two children of equal mass sits on either sides of seesaw, they will be in equilibrium unless one of them pushes itself down. So two children are here having equal mass, seats on either side of seesaw, they will be in equilibrium unless one of them pushes itself down. Yes, here you can see that one, when that beam balance, when that seesaw is in equilibrium condition, when d1 is equal to d2 as well as m1 is equal to m2. d1 and d2 stand for distance of one boy from the fulcrum and distance of second boy from the fulcrum. Both are sitting at the same distance from the fulcrum and at the same time both are having same mass, that is m1 and m2, or m1 is equal to m2. In that case only it will be in equilibrium condition. In the horizontal position, the moments acting on either side of seesaw are balanced. But if one of the children change its position with respect to the pivot, the seesaw will rotate about the pivot. Here you can see that one, d1 is greater than d2. That means the distance of right hand side boy from the pivot is more as compared to left hand side boy. So here d1 is greater than d2, but mass, both are having same mass, that is m1 is equal to m2. But because that second boy, that right hand side boy which is having m1 mass is change its position more or sit more distance from the fulcrum, so it will be unbalanced. Okay, the rotation of the seesaw shows the presence of the unbalanced moment. Here the unbalanced moment is produced due to the unequal distance of the applied force from the pivot. Hence we can conclude that the moment depends on force and distance from the point about which the moment is calculated. So here we can conclude that one, that moment, principle of moment depends on the force which is acting on either side of that balance seesaw or beam balance, whatever it may be, and distance from the point about which the moment is calculated. It is depend. Okay, and the rotational equilibrium is the condition of the balanced moments about the axis of rotation. When the moments acting on a body are balanced, the body will achieve the rotational equilibrium and it is called the principle of moments. So when it attain that equilibrium condition, rotational equilibrium condition, then it is called principle of moment. Let's verify the principle of moment. The moment is defined as the product of force and the perpendicular distance from the pivot point or fulcrum. The unit of moment is Newton meter. The clockwise moment is considered as positive and the anti-clockwise moment is considered as negative. Here you can see that one. Now consider a rod pivoted about the point O. Let us consider a rod pivoted about the point O, or the fulcrum is present at a point O, and a mass of 20 kg is hanging from the left end of the rod at a distance of 0.2 meter from the pivot. Left hand side 20 kg force, 20 kg mass is hanging, and the distance is 0.2 meter from the pivot or the fulcrum. Another mass of 10 kg is hanging from the right end of the rod at a distance of 0.4 meter from the pivot. Okay, so here W is equal to m into g. W is equal to weight, m is equal to mass, g is equal to acceleration due to gravity. The weight of the masses or the force acting on either side of the rod will be given by this one. W is equal to mg. W1 is how much? 20 into g Newton, where g stands for acceleration due to gravity, and we are taking that acceleration due to gravity as 10 Newton. So W1 is equal to, we can calculate that one, 20 into 10 is equal to 200 Newton. Okay, the gravity force W1 due to 20 kg mass is 200 Newton. The gravity of force W2 due to 10 kg mass is 100 Newton. Exactly like that only we can calculate here also. Yes. So anti-clockwise movement is equal to W1 into 0.2 meter is equal to 200 into 0.2 is equal to 40 Newton meter. W1 will create an anti-clockwise moment about the point O, and it will be that one, previous one. So here clockwise moment is equal to W2 into 0.4 meter is equal to 100 into 0.4 is equal to 40 Newton meter, and W2 will create a clockwise moment about the point O, and it will be given above that one. Okay, so clockwise moment we have found by applying the same formula, 40 Newton meter, and anti-clockwise moment we have found, that is 40 Newton meter. Both are same. If we compare, the anti-clockwise moment is equal to the clockwise moment. Both are same only here. Hence, as per the principle of moments, the rod will be in rotational equilibrium condition. It will be not moving any side. Okay, it will be in equilibrium condition and it will remain horizontal only. Let us revise what we have discussed. According to the principle of moments, a body is said to be in rotational equilibrium if the clockwise moments are equal to the anti-clockwise moment. Anti-clockwise moment is equal to clockwise moment. The beam considered is under rotational equilibrium by the principle of moment. This much only. Thank you.